Intracellular signaling is going to be what happens after that ligand has bound to the receptor, and we are going to be communicating that information to the cell, the inside of the cell, and ultimately getting the response that we're hoping to get. So basically, how does the receptor tell the rest of the cell that it does need to respond? There are different ways that this can be communicated to the inside of the cell and throughout the inside of the cell. So we're really just looking at the most common methods that would be used. So one of the most common chemical modifications that would take place is going to be phosphorylation. We will have a number of different enzymes inside the cell that are capable of phosphorylating specific substrates. So one specific type is what we call a kinase. So there are many kinases that do get involved with signal transduction and propagating or passing along this information. And so these kinases, they are typically named for the substrate that they're actually phosphorylating. So we'll see sometimes they're called tyrosine kinases or serine kinases, but they are adding a phosphate group to a molecule. So if you have a substrate like this, they'll basically come along and they'll add a phosphate onto that. A common one is that GMP will get a phosphate added to it, and it will then turn into GDP. And we can actually add yet another phosphate onto the GDP, and it can be turned into GTP. And that GTP, that GDP, they will have specific effects that they exert inside the cell once they have been phosphorylating. So this phosphorylation that we're getting, this specifically is going to cause the activation and in some cases the deactivation of specific molecules. And doing this will help to spread the signal, or in some cases it's actually going to terminate the signal if we're deactivating something. Another type of molecule or group of molecules really that gets involved in this passing along of the signal is what we call second messengers, or sometimes they're called secondary messengers. And these are going to be small molecules. We have a few examples of them, but these are small molecules that we say they propagate or spread the signal, spread the message. And so these, many of them are calcium ions. So that's a very common one that's used. Calcium ions a lot of times are compartmentalized into certain areas of the cell. And then when a signal is being passed along, these will be released from their compartments, and the rest of the cell will notice that there is this sudden increase in the cytoplasmic levels of calcium ions, and that will cause some type of response. Another example of one that we have is what we call cyclic AMP, and we call that one CAMP for short. This one is going to bind and activate a specific kinase enzyme, and that will be the effect that it exerts. In addition to this, we have some particular parts of the membranes that do get involved as secondary messengers. Some of the phospholipids have some pieces that do get involved. So when we're propagating the signal, it's basically enzyme activity, a lot of phosphorylation and dephosphorylation, and then also small molecules that will be very mobile inside of the cell, and they're going to be called secondary messengers. And these secondary messengers are going to continue to spread that signal throughout the cytoplasm so that we do end up with the desired response.